I built Sample Forge for 3 main reasons. I needed to be able to perform deterministic inference on any large language model of my choice that I can run locally, so that I can compare changing various parameters like temperature, top K, repetition penalty, and so on, and then see the effects that those sampling parameters have on the response of the large language model. Also things like system prompt. Another thing that I built it for is I wanted to run live bench reasoning benchmarking on large language models of my choice, so that I could also check the performance of those various sampling parameters on the reasoning ability of the large language models. Also test things like perplexity between various quantizations of those large language models, and also see, hey, which large language models are smarter or better at reasoning than others, because I don't exactly trust the public benchmarking that we get from the various large labs. And the third main thing I built it for is the ability to find automatically the best sampling parameters per any model. And that's what I did with this application. I call it ACO, or auto mode. What it does is automatic convergence optimization. So overnight, you can just leave it, and what will happen is the application will automatically converge on the best sampling parameters for any large language model. That way, whenever you wake up, you look at the numbers and you'll be like, feel very confident that those particular sampling parameters are going to give you a reasoning boost for your large language model. And as you can imagine, these things are very useful for research purposes, or if you're working at a large enterprise company and you want to be able to boost the performance of your large language model by 10% or 20, 30, whatever, you might be able to do that if you find the proper sampling parameters. So let me go over really quickly on those 3 main things, and then after that I will go into a deep dive of all the various capabilities of this application. So if we were to test the deterministic capabilities of this application, you can type in anything you want here, like, hello, how are you? And if I run the inference sample, there's the output. And you can see that the slots endpoint records the raw decoded output as well. And you can see we'll have 55 tokens generated. You can also check the slots endpoint right here. If we refresh, we can see 55 tokens decoded. And we can see all the exact parameters that we ran with. And if I was to run this again, I'm going to get an identical answer to this. So let's run it again. And as you can see, 55 tokens decoded and the answer is identical. And just to show you that it's not like some shenanigans or memory or cache issues, let me copy that and just put some nonsense in here and then run that. You can see decoded 34 tokens here. There you go. And now if we run exactly the same question again, notice how it's 55 tokens again. And every single token here is in exactly the same position, all that. So now we can start tweaking, either the system prompt or either the temperature and see the response and know with 100% certainty that, hey, it's start making correlations. Like if I was to change the temperature to 0.2 and run that test. So now we can see, it decoded 60 tokens. So there's 5 more tokens, and we can see the difference that it also makes in the response. So as you can imagine, very useful for researching purposes. So now we're back to 55. One thing you need to keep in mind whenever you're messing around with this application is that you need to really pay attention to everything that you do, because large language models are extremely sensitive to the parameters that you use, but also the input. For example, the large language model doesn't see words. What it sees are tokens, and a space token after your question mark is an extra token, and therefore you're bound to get a different response. Like if we're to run this right now, because we have an extra space at the end there, right now it's 55, so it's the same answer, but a lot of the time you could get a different answer just because of that extra space. Or a new line, like if we put a new line and then we run it, it is quite possible that we're going to get a different answer. So if you're going to want deterministic results, you need to make sure you put exactly the same inputs, okay? So you're always going to get the same output as long as you put exactly the same inputs. And that is just the basics of this. So let's go into the benchmarking. So now in order to test various models automatically, like if you want to, let's say, test Gemma here and see how well it performs in the reasoning data set, all you have to do is give a name to the data set, select the reasoning data set questions, and I'll go into deep dive eventually how I got those and everything. Select the server config, select the API config, the questions that you want tested on. Let's say, for example, 1 through 3 for now. Okay, so we don't want to test all 100 questions, and just click start. And then what's happening is the server will restart, and it will automatically show up here that it's going to be running the questions. And what's happening is basically there are reasoning questions that were downloaded from LiveBench, and those are being asked of the large language model of our choice, in this particular case, Gemma. And then they're automatically being scored on whether the large language model answered the reasoning question correct or incorrect. And it runs that reasoning benchmark with the parameters that we chose. So in this particular case, temperature of 1 and top P of 1, top K of 0, and min P. And you can score it in the middle of the run. You don't have to wait. All you have to do is just click score. So right now it's not done with the last one yet. But once it's done, a pop-up will appear. There it is. And if you click yes, you can just go to the folder because everything is logged. I have all the metadata. You can take a look at it and see what questions it was asked and all that type of stuff, how it was scored. So that's how the benchmarking works, basically. And you can chain them together. I'll show you how to do that later. So that means you can run a bunch of benchmarks all back to back, all night long if you want on your large language models of choice. That way, whenever you wake up, you can see which models perform the best on the reasoning benchmark. So you'll know which models out of the bunch that you chose are good with your particular parameters. You can also run it against exactly the same model, just with different parameters. And then the third, and in my opinion, the most useful feature of this application is the auto mode. And what the auto mode allows you to do is simply choose the data set. Let's do something simple. Instead of 3, instead of all 100, let's do just 3. So let's do just 3. So we're going to choose 1 through 3, export to text. So we choose the data set. I just created one really quick, which is 3 questions only. Just for our purposes right now, I made it small. We choose the server configs. Excuse me, API configs, and we just click start. And what's going to be happening here is the server restarts again, and basically what's happening is first the large language model of our choice, which is Gemma, is going to be run against a baseline reasoning question with the suggested sampling parameters. It's going to score them and see how it's scored. In this particular case, we already know that it gets 1 out of 3 right. And then after that, instead of using the parameters that we had given it, there's a Bayesian algorithm inside that is going to start randomly selecting sampling parameters and testing those. And if you do this overnight, let's say 12 hours, on a large enough data set, like let's say 100 questions, usually on a 4090 or something like that, you'll have like, I don't know, somewhere around like 1,200 to 2,000 samples by the time you wake up. It also depends on the model as well. And it will give you very strong candidates for the perfect sampling parameters, and that's how it looks like for your model. And those sampling parameters oftentimes are a lot better than what the developers suggest, or they're very good alternatives. And you can also view this in real time. So what you can do is you can go to the ACO data view, and you can load the database that it's currently running. This is the one that we just started. And you can just load it and see what the suggestions are right now. So right now, the top contenders that it likes are, min P of 0.4, repetition penalty of 1.1, temperature of 1.1, top K of 320, type P of 0.9. And that's basically how it looks like, once you've loaded it. Obviously, it's going to be a lot more comprehensive once you've run on a larger data set besides just 3 questions, which is what I chose for this particular test. You want to usually run on at least 100 questions. And for a lot longer, like 12 hours. You're going to get a very strong signal at the end of that whole process. So those are like the basic things that I went over. That should give you an idea of what this tool is useful for. Obviously, research purposes and finding correlations between sampling parameters, system prompt, finding out which models behave better under certain quantizations. Hey, if you have Gemma at FP8, how much less performant is that versus, let's say, FP16? Same goes for FP4, how much IQ had it lost once you're running it at FP4. So yeah, now I want to go deeper, and I'm going to explain every single thing with this application. So let me just stop that, and we'll just start fresh. This is going to be for somebody who's going to be using my application and wants to know all of the various capabilities of this, because it is a very powerful research tool. So let's close it for now and start fresh. So the basics are this. It is using llama.cpp as the inference engine on the back end, and that is how my application runs it. What you see at the very front is going to be the various tabs that have their own uses. You can change the theme here. So if you want something that's a little bit more friendly to your eyes, you can change it to that. I prefer Sunset 70s. Yeah, so let's start with the server configs. The server configs are basically the flags that you would manually have to type into the terminal whenever working with the Llama server. But because we're doing this through user interface, you don't have to do that. You could just do it here. And I made it easy by providing an example server API parameters that fills in. Usually for most people's purposes, this is what you want to start it with. Also, it starts with the most deterministic settings, because if you get any of the settings wrong, you're not going to get deterministic behavior. It's very important that you get the server startup settings correct and the API parameters settings correct. I have extensive tooltips for all of the flags that we have available for us. That way, if you're somebody new and you're learning how to use llama.cpp, You can just hover over the tooltips and they'll tell you what they do. If you're brand new, the most important things are your executable paths. So that's going to be where your llama.cpp server is. So you can just select that. And then also your model, where that is. For me, there it is right here. Once you've selected those, you can just save them, name them whatever you want. Usually I like to name them after the model that we are running. So I already have it saved as Gemma. So if I click Gemma, there it is. It loads it automatically. So let's look at a couple of these flags just to familiarize ourselves with it. Host is obviously where we're going to be running. Port is going to be the port. Let's see here. So number GPU layers. If you are somebody who does not have an NVIDIA GPU and you're going to be running this on your CPU, obviously you're not going to be putting 99 here. You're not going to be offloading anything to the GPU because you don't have one. Let's see, what else? Context size. I have context size of 12,000, and that's the way I like it. Through my own experimentation, I found that that's usually the cutoff where a lot of the models, not all, but a lot of the models start to, degrade in performance in their reasoning abilities. So, don't believe in the hype. Whenever you see like Qwen 3 saying, hey, we'll have 128K context and stuff like that. Yeah, technically, yes, but is it usable? No. I found actually for Qwen 3, usually it's around 16K. It starts to degrade. But for our purposes, I set it to 12,000 because the reasoning questions are pretty complex, and it can take the model a long time to answer it, and sometimes these models go over like 32,000 tokens. And in my minds, for me personally, I'm like, look, if you haven't answered the question within 12,000 tokens, might as well mark it wrong. I've made lots of tests in order to see and test that hypothesis, and what I found is that if you, let's say, leave the context size at around 32,000 tokens, you're going to get tiny bit better performance, meaning that there are outlier questions out there in the reasoning dataset 1, 2, or 3 that you would have gotten right if you let the model reason for that long. But in my mind, it's not worth the trade-off, the time trade-off to let the model keep thinking for that long. So I just cut it off at 12,000. Like, bro, get on with it, answer it within 12,000 context or it's wrong. So that's why I leave it at 12,000. I recommend as well. Batch size. We're not going to touch that. You're going to leave all of that. So all these you're leaving. You want to leave flash attention as on. Strongly recommended because you're going to get a little bit faster performance with it. And I actually made some tests. The models perform just as well with flash attention on as they do disabled. So you might as well have it on. One thing you want to turn off is no continuous batching. You want to click. Actually, that's not the one that matters. The one that matters is going to be cache reuse. You want to set it 0, and also I think there's one over here somewhere. Yeah, no contextual shift. You want to click send that as well. That's just for deterministic inference. You just want to change those. Ginger template. A lot of these models come with their own template, especially the GPT OSS model. So you definitely want that on 100%. You are not going to get good performance out of the GPT OSS models if you don't have that on. But that actually starts to apply with a lot of the newer models from Qwen as well. So I'd usually leave that on because that template is very important for reasoning capabilities of your model. So once you launch, you can see the terminal that it's launching. There you go, it's launched. And now we have our server, and now we can perform inference. You could technically actually just perform here without filling out anything in the API here. You could just say hello and see what it'll respond. There you go. And as you can see, it's always changing. Obviously, it's always changing is because, well, we haven't frozen the seed and we haven't loaded in the deterministic API parameters. So I provided an example here. And the most important thing out of this whole thing is going to be the seed. You want that to be frozen. So you want to change it to 333 or whatever you want. And also you want to have the cache prompt send as false. So you want just like that. And now you have deterministic behavior. So now whenever you write anything, you know, random gibberish, for example, here, we can see that it decoded 37 tokens. Let's run it again. 37 tokens, exactly same position. You know, no matter how many times you're going to ask this question, you're always going to get exactly the same answer, no matter what. That's the whole point. Now you can, again, start seeing the performance, you know, change it to like 0.9, you know, and see how that's going to affect, you know. Obviously, this is like very simple stuff. What you actually would want to do is you would want to look at a reasoning data set. And for example, you have this question, which is one of the reasoning questions from the live bench. And if you paste it in here and then you run it, it usually takes about 15 seconds for Gemma to answer this question. So if you look at the data set, the ground truth is 1 filmmaking, police officer, journalist. That's the answer you expect, the correct answer you expect from the model, right? So 1 filmmaking, police officer, journalist. And its final answer was 1 collecting, police officer, journalist. So it had made a mistake. So this would be marked as wrong by my automated system, okay? But now that you've run it, okay, so check this out. 570 tokens decoded, right? So I had to pump out a lot of tokens in order to get this answer. If you run it again, you'll see the answer will be identical. It will be 570 tokens again, and the output will be identical in every single way as before. And what you would do usually manually to start seeing the correlations between your sampling parameters or your system prompt is to start to manually adjust them. So there it is, 570 tokens and exactly the same answer. See, 1 collecting, police officer, journalist. So now you would say, okay, well, what if we, you know, use like a temperature of, let's say, 0.8, you know, top K of like 40, and then like top P of, let's say, 0.2, okay, and, you know, min P of like, I don't know, 0.2 as well, for example. And you run that exact same question, right? And you're like, is it going to get it right? Well, we don't know, right? Because we don't know what mix of these parameters. So I have to sit here manually. There it is. There's, okay, let's see what the answer is. 1 collecting, police officer, journalist. So we can see it's the same response as far as the incorrect response. Obviously, you're going to have a totally different answer from before. It phrases it differently. The thought process is totally different and all of that. So there's a difference in that. But in the end, the reasoning trace, the response, is incorrect. And you could sit here forever, you know, fiddling with these numbers, and also fiddling with the system prompt saying you are a friendly assistant or think step by step, blah, 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 whatever it is. But that's very, very tedious. We don't want to do any of that. We want to automate all of that. And that's where the benchmark comes in, right? The Run Benchmark tab allows you to automate all of that. And the way you would do that is you would first save yourself a bunch of your own API parameters. So for example, this one, we could say Gemma temp 1 right? And then if we change it to 0.8, we could say Gemma temp 0.8, right? So you want to just compare those versus like let's do like maybe 0.6, right? And you would say Gemma 0.6. Okay, great. So we have now, you know, 3 different API calls. They're identical in every way. The only thing that's changed is we've changed the temperature, right? So what you would then do is you go to the run benchmark tab and you would say temp compare Gemma, for example. You give that name. You would load in the data set. So it'd be like, for example, let's say the 3 questions. So instead of all 100 questions, which I recommend because that's what you would do overnight, you want to just really quickly test 3. So you just say just 3. Okay, so that's the data set we're going to use. We're going to choose the Gemma server. So the server configuration is going to be exactly the same because we're using the Gemma model, right? Then under API parameters, we're going to choose the top one, Gemma temperature 1, for example, right? And this is going to be temp compare Gemma 1, right? Because that's the temperature of 1. Questions 1 through 3. We're not going to start right away. We can. If we click start, what will happen is 3 reasoning questions will be run of temperature 1 and these other parameters here. Everything exactly as you see. And it'll score them as well. But we don't want to do that because we want to compare it to something else. So we'll click the add button. And now we have run 2. And for run 2, we're going to rename it real quick. Ask the same questions. Same server. And now instead of 1, we choose 0.8, right? Because we saved that earlier. And then if we click add 3, same thing. We're going to choose, instead of 0.8, we're going to do 0.6 because that's what this one's about. And we're going to just double check real quick. Make sure that the questions are chosen. All right, so everything looks good. Then we just simply hit, we could save the chain if we wanted to. Saving the chain saves a JSON file on the desktop so that we could just load this whole process so we could continue it later. I'll show you how to do that. Just click on desktop. So chain 01, for example, and you can just load the chain. There it is. But we're not going to do that right now. You just click start chain. And now what's happening is if you look on the slots endpoint, slots endpoint is what the llama.cpp server actually processes. So we can actually see it asking the questions. See, it's decoding as we're going along. And you can see the temperature that it's using here and all the other parameters. A couple of things you want to keep in mind is some of these numbers don't exactly match up to the API parameters to the T because llama.cpp runs things in floating point, right? So even if our top P is 1 or whatever, the way that things are run, llama.cpp, like for example, repetition penalties, you can see it's not 1.1. It's 1.1 with some, some exponents in the back there. And that's normal. These are still deterministic, meaning that those numbers are still identical. So if you put 1.1 in our app, the 1.1 will always equal this number. But just so you understand where the discrepancy is coming from, okay? And what's happening is we can go into the scoring tab and we can see things that it has already run. So like, for example, it is running the 0.8, but it's already completed the 1. So we can score it. We got 1 out of 3. 8. Let's see, it's not done. It's doing only the second one right now. And yeah, so that's how you would do it semi-manually, okay? But that's still not fast enough for us, and it's still not convenient enough because you have to fiddle around with creating API parameters over here. It all looks very confusing, and just it's too much. So for that, I created something else, which is called the auto mode, which is brain dead simple. So let me stop the benchmark here, actually. Let's see, there it is, it's scoring. I'm gonna stop this for now. And let's check this. Just gotta wait a little bit. Whenever you stop anything, it doesn't stop it automatically. It lets it finish. There you go. And we want that because we still want the model to answer the last question, because we could always resume at any point in the future. Anyways, all of this is too much. Let's go to auto mode, which is brain dead simple. Auto mode, again, you choose the data set. Let's say these 3 questions that we chose. You choose the server. You choose the API parameters. Let's go. Actually, it doesn't matter here which one it is, because it's going to start diverging away from those first. So we just go Gem8. And then just click start. And here what's going to happen is it's going to establish a baseline by answering those 3 questions first. See out of those 3 questions how many the baseline got correct or wrong. And then based on that, it's going to start diverging away from those sampling parameters so that it can find better sampling parameters. And this is what you would do overnight once you sleep. You would simply run it here. Again, instead of the 3 questions, you'd want to run the 100 questions, because the more samples, the better. But you're also constrained by time, so you don't want to do like 1,000 questions or something like that. I find that 100 questions is usually good. And then in the morning, once you wake up, it gives you, the sampling parameters that the model had behaved the best with. So very, very useful. Now, one question you might be asking yourself is, well, are sampling parameters, these numbers right here, are they really that important? And the answer is yes and no. So they're important in that there's like a normal distribution with the sampling parameters where most large language models behave very well. And you will start seeing the correlation once you run this enough times and you played around with large language models enough. But the correlation that you'll see usually is anything that's like around temperature of 0.7, top K of around like 40 or 60. You'll start seeing some correlations, okay? So that means that, the worst performing sampling parameters are usually on the lower side of things. So usually like temperature of 0 or 0.2, 0.3, anything below 0.5 doesn't behave very well. But once you get in the Goldilocks zone, they act pretty much the same, all the way up to like temperature of 1.2 sometimes. But you don't know what those numbers are, right? Which is what that application is for. So it does matter once, for you to get into the Goldilocks zone. It doesn't matter in that once you are in the Goldilocks zone, the distribution, as long as you choose something within that range, you're good to go. It's a good way of finding alternative sampling parameters for diversity in your large language model answers, something that is more creative, more varied, and maybe behaves differently than what some of the more like boring sampling parameters allow for. But as you can imagine, system prompt is one of the most important sampling parameters that you actually have. So that's where this application really shines also, is that it allows you to test many different type of system prompt. So instead of changing things like temperature, top K, top P, min P, whatever, you can change things like the system prompt. And you can see, hey, how does the model respond to your reasoning questions if you told it that it's an assistant versus if it's like a math professor? Okay. All of these things can be very easily tested here and automatically tested. Same goes with auto mode. You can just have auto mode converge on the best system prompt. But that's in later videos. I'll show you how to do that because it gets a little bit more complicated with this right here, which is an array. What happens with the array is here you'll be choosing an array of your own preferred sampling parameters, and there's an array for a system prompt as well that you can choose, and you can basically steer the model however you want towards using your specific array instead of having the application choose it randomly for you. Let me see some closing thoughts for now. Yeah, so basically, you can play around with all of these. As you can see, there is a lot of sampling parameters, to play with. There's repetition penalty, which is very important. I recommend usually having that at least at 1.05. But what it does is it prevents your model from spiraling into itself, which happens quite a lot, especially on longer context conversations. Let's see. Let me talk a little bit about the data conversion tab. The data conversion tab, so this is where the loading of the live bench dataset happens. So as you can imagine, writing your own questions is a pain in the ass in order to test these models, and that's what live bench is for. So I've integrated some of the code from live bench into my application. Whenever you click the load complete dataset, what it does is it pulls the most recent live bench questions. And once they're pulled, it saves them as a metadata on the computer. And then all you have to do is click browse questions. And now you can browse them and use them for this application. Not all of the live bench tests can be tested on with my application. For example, coding, I think language, and possibly instruction following. I'm not sure. You can't test those with my application. And the reason is because the questions for those categories require another large language model in order to grade it. And as you can imagine, performing an API call on your local model in order to ask the question, and then performing another API call in order to answer it is very time consuming. So now you had just doubled the amount of time it takes in order for you to score the answer, whether it's correct or not correct. And I decided to go against that for time's sake. So that's why I recommend usually using just the reasoning data set, like the zebra puzzle, spatial, whatever, because I have an algorithm inside the application that does a very good job of scoring those automatically. That doesn't require any large language model. And I've tested it many times. It's pretty good. It's very robust against false positives. So that's why I recommend that. Obviously, you're always free to browse through them. I just wouldn't recommend using some of the categories that I suggested for the testing purposes. Let me see what else. Whenever you're doing manual testing for your model, like let's say I like coffee, right? Oh, I'm performing a test right now, aren't I? Let's see. Yeah, it's decoding right now. I forgot. Oh, I forgot all about our auto mode. Yeah, so let's take a look at the ACO data view. So it's already started converging on some of the sampling parameters, and you can view that live again in ACO data view. Let's take a look at the most recent database. And you're always going to see the top favored parameters at the top, and also the value pairs here. So right now it's really liking these parameters because it's getting 2 out of 2 correct. So let me explain a couple of these things. So coverage is how many questions out of the full data set. So we gave it only 3 questions for this small test. How many of those questions were asked? So here it was asked only 2 out of 3 of these questions. And this number that tested means how many it had passed. So it was asked 2 out of 3 of these questions, and it passed 2 out of 2. So 100%. So meaning that with these sampling parameters, minimum P of 0.4, repetition of 1.1, temperature of 0.9, whatever, it passed every single question that it was asked. So that's why it's the top contender. Whereas something like number 6, for example, here, it was asked exactly the same question, same coverage, 2 out of 3. But as you can see, these sampling parameters got only 1 out of 2 correct. So as you can see, sampling parameters matter. They matter quite a lot until you get to the Goldilocks zone. So that's why you want to know what sampling parameters you should be using. Because that could save, if you're working for a large enterprise company and you're using one of the large language models, so let's say you're doing things on base, you're not paying for API for privacy reasons, right? It costs you millions of dollars per month to run that model. If you're training your own models, then it's going to cost you even more. So, let's say you want like a 15% bump in reasoning capabilities of your models, or 15% performance improvement. Well, instead of retraining it, use better parameters. And that's what this tool allows you to do. But also, besides that, you can also validate any of your hypotheses regarding, quantization. If you're running FP8, for example, for your company, that's costing you a lot of money that you could be saving if you could get away with reasoning traces that are identical, but they're FP16, because now you have to use less compute, right? So you can test that with my model. All you have to do is go into run benchmark and just chain 2 runs together. One of them is going to be FP8, which is the model you've been running, and the other one FP16. Run it on 100 questions, exactly identical parameters in every single way, and see, the performance drop that you're going to get with FP6, if any, right? And then you'll be able to see, okay, well, if we go to FP6, our performance is going to drop by, let's say, 15%. And you're like, okay, well, is that 15% performance drop worth us saving, $3 million per month, for example? It might be sometimes, because that's exactly what you're finding with a lot of these third-party API distributors. A lot of them are, if not all of them, are not running FP8. A lot of them are running FP6, FP4, because it's expensive to run at higher quantization levels. Let's see what else real quick. Yeah, so if we load the database again, yeah, things are not changing. I mean, it's only 3 questions. So you can stop the whole process for the auto mode. So for some reason, if you need a break on your machine, you can always resume it later. So once you had stopped it and you verified it, let's check in slots. Yeah, it looks like it stopped. You can load it again. And all you have to do is just come back. Let's say you open your application, you go back to, all you have to do is set up the things identically, like the dataset, the server config API. And then all you have to do is click load run database and then just select the database. And then all you have to do is click start, resume. And then what will happen is that instead of starting the whole process all over again, like asking the 3 questions and stuff like that, it will just resume the automatic convergence. Let's see if it's running. Yeah. And right now it's choosing top K of 160. So that's what it's preferring. So that way you don't lose any runs if you had some sort of catastrophic failure or, somebody pressed a button or something like that. Because the longer that you run the automatic convergence optimization, the more sure that you can be that the sampling parameters that the application is spitting out for you are the best parameters. And I usually find anywhere between 12 to 24 hours is about the best time for that. Let me tell you a couple of things that I found as well through my research of using this tool. Large language model reasoning capabilities drastically matter between large language models. So you definitely want to be testing as many models as possible, as much as possible, because the variance is insane. For example, right now we're using Gemma. On average, I find that Gemma, with the reasoning questions that we have running here, performs at about 26% accuracy. That means that out of 100 of the reasoning questions, you're going to get about 26 correct, which in my opinion is very poor, at least for reasoning. This is a Gemma 12b, by the way, instruct. If you choose a model like Qwen3 4 billion instruct, a model that has a lot less parameters, still an instruct model, that model has an average accuracy of about 80%, which is pretty nuts when you think about it for such a small model. When I first tested Qwen3 with these results, I was extremely surprised, and I was also very weary because I was thinking maybe it was somehow benchmaxed, which is not out of the realm of possibilities, right? The only reason I don't think it was benchmaxed is because the more I played around with it, it seemed like the model was really good, and it was performing pretty well besides just the reasoning tasks, so on my own personal tasks. And also LiveBench tends to change their questions. And the cutoff data set that the Qwen team had trained on, at least what they claim, is way outside the window of this data set. This data set that we test with on this application came out way after the training had already completed on the Qwen3 model. So technically, it's impossible for them to benchmax on this particular data set if what they're saying is true. So there's that. If they're lying, well, so be it. But at least from my experience working with Qwen3 4b instruct, very powerful model. So yeah, the reason I bring these up, Gemma and Qwen and other models, is because the reasoning capabilities change quite a lot. The accuracy is very different. Their instruction following is very different. So don't trust the things that the developers are telling you as far as how capable the models are, or not, because you'll find once you start using them that a lot of these things are just, blowing hot air. And in some instances, you'll be like very, very surprised that it actually performs way better than you had ever imagined. I want to talk a little bit about also GPT OSS. GPT OSS, I've included an extra OSS API for it. Let's stop this process for now. And the biggest difference with GPT OSS is you have to have, obviously, the Ginger template turned on, which I talked about over here in the server. There it is. You have to have that flag on. But besides having that flag on, you also have keyword arguments that are very important. So right here in the chat templates control, chat templates keyword arguments, you need to have this right here. Right now it's set to medium. You can set it to low or you can set it to high. Because without that special template, GPT OSS is not going to behave correctly. So a lot of people were having issues with that model. Let me load it for you right now. I don't have it. That's fine. Wouldn't need to go into it. But a lot of people were having issues with the model, and that is because they were not loading it properly. A lot of the newer models, not just GPT OSS, but Qwen, new models, and a bunch of other funky models, they have their own keyword arguments, their own templates, and their own special way of running. And if you don't pay attention to that, it's going to bite you in the ass because you are not running the model as intended. So once you have these keyword arguments for GPT OSS, you're good to go. If you do not have those keyword arguments, it's not going to behave properly. Some last thoughts. I also gave the ability for, let's do that one. For instead of chat completions endpoint, I also have a text completions. And that basically forces the model to behave in a manner that completes your sentences instead of responding as an instruct model. So if I say I like ice cream and I run it, you see how weird the responses start coming up? And that's because instead of running it as an instruct model, so here's how it would look like an instruct, which is a ping pong relationship. You ask a question or you make a statement and then the model responds to that statement. What it does is it takes the input here and it just runs with it. It starts completing the sentences. So for example, if you say, here is how you make a bomb, and if you click that, what will happen is the model will try to continue on completing this sentence in the way that it was pre-trained, of like what data it saw during pre-training. And that could be very useful because for research purposes, it can give you an insight into how the developers had put the model together. So here it's completing the sentence in the USA, you're pulling my leg, this request is dangerous, blah, blah, blah. So you can see that Gemma team, the way that they had reinforced the model to refuse this is with this type of data. So this is just purely for research purposes, but it can be very useful in order for you to understand the model a little bit better, for jailbreaking or for things like that. Yeah, I've gone over most of the basic things, I think. Yeah, so I think I can call it here. If you have any questions, you can email me. I have that info down in the GitHub About page, or you can talk to me on Discord. I'll also link that. And that's about it. All right. Have a good day.